Sorry, sir, I joined a little late.
Hmm. Kanishka is also late. You are also late. I was about to end the class. I thought some problem is there. But again, you both joined. Hmm. See, we were about to start. Acha, I'll teach you the basic probability today. Basic probability and the introduction to 3D geometry is there in your class, in class 11. So first you need to understand few terms related to this. See, in probability there are few terms. Probability is what? Probability is the percentage. Means it's like a percentage of calculating by how much percentage the thing will happen. Means it's calculating the chances basically. It actually helps in our calculation also so much in predicting things. Now, when we learn probability, we need to understand few terms before learning actual probability, that this thing will actually build your basics and which will be actually helpful in your class 12 advanced probability. So first you need to understand the experiment. What is an experiment? Experiment is an operation which can produce well-defined outcomes. Okay, it's like tossing of two dice. How many outcomes can be there? You can find out. Total 6 into 6, 36 will be there. Yes, 36 outcomes will be there. What I'm telling you, suppose I have tossed two dice. You know about dice now? Dice has 6 faces, each with number 1, 2, 3, 4, 5, 6, like that. Two dice are thrown. Means how many cases that you can form? This is an operation. Operation is the throwing of two dice. Okay, this is an operation. It will have actually well-defined outcomes. It will have well-defined outcomes means numbers. Either it can have 1 1 or 1 2 or 1 3 or 1 4 up to 1 6, then again 2 1, 2 2, like that. All possible cases in which if last it will go up to 6 6. So total, if you want to calculate, it will be 6 into 6, that is 36. This you must have learned in what? Permutation and combination. Any number, any side can be chosen in 61 ways. Any side of this can be chosen in 61 ways. The event completes by taking this and this. So 6 into 6, 61 to 61, 36 total outcomes. Understood now? Okay, now you have understood what is an experiment, operation, what are the outcomes, and now I'll teach you about events. Do you know something about event? Events are simple things only. Actually, these definitions they won't ask. It's not useful. Event is something, some event. Event may be of different types. Simple event. Let me just list them out. Compound event, sure event, impossible event, all common things, common sense things. Simple event in mathematics means has only one sample point. You're able to understand, no? You're understanding these things? Haripriya? Are you listening or not? Haripriya, Kanishka?
I am. Yes, sir, I am.
What is a sample point? This is known as sample space. All the outcomes consist of sample space. All the outcomes of an event of an experiment are the sample space. Simple event means it has only one sample point. Means you will get only one sample space, one event in a sample space. Compound event means it has more than one sample points. These definitions are actually not useful because they won't help in solving problems. Sure event means which is sure to happen. Impossible event means which can't happen. All basic things. Now you may be thinking, what is the use of all these definitions? Now comes important things. Equally likely. Equally likely events. See, two events are said to be equally likely when the probability of occurring, means the chances by which one can occur, is equal to the chances by which the other can occur. Means, suppose you give an exam. There are equal chances of you getting passed and the equal chances of you getting failed. Because either you will get passed or you will get failed. Or if I throw a dice, the probability or the chances of me getting a number for every number is actually, number is different, but I can get anything, na? So there are actually equally likely events. Any event can occur, and nothing is less or more than the others. Every getting a number is actually same, so they are supposed to be equally likely. When happening of one event is not in preference to other. Mutually exclusive. See, these definitions are actually important because they will be helpful in solving problems. What are mutually exclusive and if occurrence of one event excludes the occurrence of other event. This you understood or not? Just try to see what I am telling. See what I am trying to say now. If E1 is an event, E2 is other event, then E1 intersection E2 is equal to 5. Means there is nothing in common between event E1 and E2. Let's say E1 is 1, 2, 3. Event E2 is by numbers, if I say 4, 5, 6, then these events E1 and E2 will be mutually exclusive events. Okay?
Yes.
Okay. Now let's move on to the next. Next is exhaustive events. These two definitions are very important, the above two, equally likely and the mutually exclusive. What are exhaustive events? Exhaustive events means combination of all such events which are exhaustive events. Combination of all such events will actually complete the sample space. That's what is the meaning of exhaustive. Let's for example, if E1, E2, E3 are three events, then E1 union E2 union E3 is equal to S, where S is the sample space. You know about complementary events?
No, sir.
Don't know. In set theory, I have discussed complement. Na? Means if I say, if I have this one, this kind of thing, this is a set, some set U, or I'll say P, and there is another set which is A. Now A complement is what? A complement is like this, AC or A dash. It is P minus A. Understood now? Means what the area, the region which excludes A is known as the A complement. You can say complement, the two things which are complementary to each other complete each other. Means if A is a set, the complement of A will be every other thing excluding that particular set. Understood? Now let me tell you about algebra of events. From here things will start actually. If there are, if A comma B are two events and I say A or B, it means what? A union B. Union you already know because I have taught you the set theory. A and B will be what is this? Wait. Actually, A and B is A dash union B dash. Mhm. A and B, it will contain the common intersection. So, no, 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 no. Other thing. Uh, A union B whole bar or A dash intersection B dash. That is the A and B. See, actually, what I would suggest you, na, you should take the help of, if you are solving probability question, this basic one, you should take the help of this Venn diagram that you have already learned. When A and B two sets are there, you remember now when A and B were there, if they are asking A or B, that means A or B means this whole area. Actually, A and B will also be same. The answer should be same only. A union B. Both should be same. A but not B. A but not B means the region that we are actually want this region. So you have to do A minus B. At least one of A, B, and C is equal to A union B union C. All three of A, B, and C is A intersection B intersection C. These are few mathematical representation that actually we actually know this from the Venn diagram, means the set theory, but just I am just reminding you exactly two of A, B, comma C will be A intersection B intersection C dash union A intersection B dash intersection C union A intersection B intersection C. No, this we have done. What is left? A is left. A dash intersection B intersection C. This. These are few representations that you should remember. If any other representation occurs, you should take the help of the set theory, drawing the Venn diagram, and then solving it. Now see, now let me tell you about, these are the basic things. Now from here, the basic probability which is actually present in your examination will be, I'm telling you now. What's the probability? Probability of an event is equal to number of favorable outcomes divided by total number of outcomes. This is the only formula that you will be using to understand this probability, to solve all the questions of the probability. Let me give you an example. Event of tossing of 3 coins. See, let me explain you what we are doing here. I have actually tossed 3 coins. Okay. Now let me explain you. When you toss a coin, this is a coin. When you toss a coin, you may either get head or tail. Correct? Yes, Haripriya, Kanishka? Now can you tell me, if I toss 3 coins simultaneously, how many all possible outcomes I can get? I have tossed 3 coins simultaneously. This coin, and this coin. Now tell me how many total outcomes I'll get. Acha, Haripriya, do you remember that in the permutation and combination I have told you one fundamental principle of counting? Do you remember that?
Right.
Kanishka,
I,
you also forgot.
yes, sir.
See, what's the fundamental principle of counting? See, whenever we are doing things or we are calculating things in a probability or we are discussing theoretically, suppose I have told whenever in my calculation or in my theoretical observation, whenever I come across a term or, that means addition is to be done. And whenever in my calculation or in my normal reasoning, observation, theoretical observation, when I am using the term and, I must multiply. This is the fundamental principle of counting. Remember this one. Now, when I am saying event of tossing of 3 coins, you have tossed 3 coins, you want to calculate total number of outcomes. You know, from the permutation and combination, you already know tossing a coin, you may get either head or tail. So how to choose if there are n possible outcomes? How to choose an outcome from this? How to choose, tell me if you remember how to choose any one object out of n different objects. Number of ways of choosing any one object out of n different objects. Do you remember? Here,
NC.
NC1. Here, when you're tossing one coin, you have two outcomes, head or tail. You have to choose one outcome. Yes, so it will be done in 2C1 ways. Correct? Either you'll get head or you'll get tail. Right? Again, here also you can choose one thing 2C1 ways. Here also 2C1 ways. Now your event gets completed, event of tossing 3 coins, when you choose the outcome of first coin and choose the outcome of second coin and choose the outcome of 3 coin. We cannot use or. What's the meaning of or here? If you put or in between, means 3 coins are tossed. I'm tossing 3 coins, but I am taking the outcome of only one coin, either first or second coin or the third coin. Understood? Because I am counting the event of tossing 3 coins, means my outcomes will be like this, either head, 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 tail, head, like this. Okay. So all total possible outcomes, how I'll get 2C1 into 2C1 into 2C1, 2C1 and this coin and that coin and that coin. So 2 into 2 into 2, that is total outcomes will be 8. How it will be? Head, 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 tail, head, head, tail, 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 head, head, tail, head, tail. Tell me more. Tail, tail, tail.
We should have 8 outcomes.
6 I have written. Head, head, tail.
HHT. I get TTH.
These are all the possible outcomes. Like this, we actually calculate how many outcomes will be there. Now this becomes my sample space or total favorable outcomes. Understood? How do we calculate? How do we make a sample space? Yes, Haripriya? Acha, can you without actually writing, can you tell me the sample space means how many outcomes of throwing two dice? I have two dice. One dice has 6 faces. What will be the total outcomes of throwing two dice simultaneously? How many outcomes I'll get? Means what will be my sample space? See, Haripriya and Kanishka, I have told you this fundamental principle of counting. Na? This is sometimes say as addition rule and multiplication rule of probability. Think and then tell me what will be the outcome of throwing two dice. Then I'll tell you about the probability, calculating the probability.
So you have to set this, say the sample size of
No, no, no.
the
No, no, you need not have to tell all those the numbers and all. You just have to tell me what will be just like I have told na total outcomes will be 8 for tossing of 3 coins. Like that for tossing of two
then it
dice.
would be 2 days, it would be 36.
36. That's what only required because this number
I
will
thought I have to tell you that whole thing.
no. That will become too difficult, too hectic. Because why I'm telling you to calculate this one, na? Because the number that you have calculated, the total sample space that we'll be using here when calculating the probability of an event, total number of outcomes, na? This total number of outcomes will be using this number 8 and 36. Kanishka, okay? No doubt.
No, sir.
Now let me tell you how to calculate the probability. Suppose I have asked you find probability of getting exactly two heads. Okay, I have asked you to find out the probability of getting exactly 2 heads. You have to see the total favorable cases. I'm talking about event of tossing of 3 coins. This was just an example. This was just an example, okay? Just to make you understand. Now we have come back to event of tossing of 3 coins. Now in the event of tossing of 3 coins, just tell me what will be the number of what are all those cases in which we are getting exactly 2 heads. Can you name them? See, one is head tail head, other is tail head head, other is head head tail, right? Head tail head, tail head head, head head tail. So how many numbers? 3. The total number of outcomes was 8. So what is the probability? 3 by 8. Understood how to get the probability? Now just tell me what will be the probability of getting one head, what's the probability? Can you tell me?
Then 3 by 8.
In 3 by 8, na? The cases will be this head, and this head. Means head, tail, 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 head, tail, and tail, tail, head. So 3 by 8, correct? Now comes one more thing. Probability of getting at least one head.
Seven by
How many? What?
7 by 8.
How?
So like at least it's like 1 and more. So only TTT has all these. So it's 7 by 8.
One head means either means it's one head, two head, or three head. We may get these cases. So one head cases we had 3. The probability was 3 by 8. Or means addition. 2 head means we have calculated 2 head. 2 head, it's again 3 by 8. And the probability of getting 3 head is 1 by 8. Very good. Correct answer. See, you see here what I have used. Getting at least one head means I can get one head, or I can get 2 head, or I can get 3 heads. More than 3 it's not possible because 3 coins are only there. So just look here. Probability of getting one head is 3 by 8. Here I have written or. I am getting one head or 2 head or 3 head. So I'll be using 3 by 8, or means addition principle I'll be using, plus or फिर again here I'm using or, again I'm using addition, because or means addition and means multiplication. Acha, now what will be the probability of getting at most 2 head? Priya, what will be the probability of getting at most 2 heads? Priya or Kanishka, anyone? What's the meaning of at most? Just tell me before that. Just tell me what's the meaning of at most.
The nil, one, or two.
1 or 2.
It will again be
Maximum you can get 2 heads. Either 1 or 2. That's the meaning of at most. At least means minimum you will be having those given heads. So 1 head or 2 head. They are the only possible cases. So what will be the probability? 1 head was 3 by 8. 2 head was 3 by 8. So total probability will be 6 by 8. 3 by 4. This is how we calculate the probability. Hope you have understood everything. Actually, up to this part only, this type of things only they are going to ask in your class 11. This is the basic of probability. Now, the formula that you apply now, that what I say, those Venn diagram formulas means the n of A union B is equal to n of A plus n of B minus n of A intersection B. Okay, for that you can apply directly. You can use probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Why? Because sample space for the whole event will be same. You can divide by sample space n of s every on the left and right, so everything becomes the probability. So the formulas that you have actually learned in your Venn diagram, this set theory, will apply for the probability also. Acha, one more important concept is the probability always lies between 0 and 1. Probability can never be greater than 1. If you are getting any probability which is greater than 1, that means your answer is wrong. Okay. Now let me give you some easy questions.
0.15.
0.15 or 2.15 you're saying? The answer,
0.15, Nasir.
oh, the answer is 0.15. See,
Oh, even I am saying 0.15.
correct. Let me solve it. Kanishka, what about you got the answer?
Yes, sir.
The probability of winning is 0.77. Probability of tie is 0.08. Probability that it will lose the game. See, they actually, when a game is played, there are only three possible outcomes that can occur. Either there will be a win, or there will be a tie, or there will be a loss. When you have considered all the possible cases, sum of all those probabilities actually 1, because the sum of all the probabilities in an experiment is always equal to 1. Remember that. Because, like, suppose we toss a coin, either we get head, either we get tail. Probability of getting a head is 1 by 2. Probability of getting a tail is 1 by 2. We can not get anything other than head and tail. The sum of them will be always 1. If you calculate, it will be half plus half, it will be equal to 1 only, like that. Now probability of loss, they ask, so probability of loss will be 1 minus probability of win minus probability of a tie. 1 minus 0.77 minus 0.08, you will be getting 0.15. Do it quickly. 5/7 should be your answer. Okay, let's end it. Few more questions I'll solve in the next class, and then I'll start the introduction to 3D geometry. It's easy only, but let's solve some more questions on this so that you will become confident.
Bye.
Bye
Bye,
bye.
sir.